So when you see an inverse trig function with the -1 on there, it means who has. And who has a sign of -1/2? Remember that you always go here first, here second, here third, and never here. So we go down here to find it, and we'll see that it is 330 degrees. Who has a tangent of 0? If you go, it's 0 degrees. That's the first one you see. Who has a cosine of 1? That's also 0 degrees, because the pair next to it is 1, 0, and that is the cosine, and that is the sine, if you remember. Who has a tangent of 1? That would be 45 degrees. And who has a tangent of -√3/3? And that would be 330 also. Who has a cosine of -1? And there's only one degree that has a cosine of -1, and that is 180 degrees. Now on these that have the parenthesis in the middle, you have to answer the question for the middle, the thing in the parenthesis, and then you answer the question on the outside of the parenthesis. So 5 pi over 6, if you look at 150 degrees, that's the same as 150 degrees. The cotangent of 5 pi over 6, or 150, is the reciprocal of -√3/3, and the reciprocal of -√3/3 is -√3. And now you need to tell me who has a tangent of -√3, and that will be 300 degrees. So that would be the answer to that one. The cosine of pi over 2 is 90. So the cosine of 90 is 0. And who has a tangent of 0? 0 degrees has a tangent of 0. So that's your final answer. Now what is the cosine of pi? That's 180 degrees, and that would be -1. Who has a tangent of -1? And that would be 315 degrees if you look at this, the fourth quadrant, the second. Pi over 2 is 90 degrees, so what is the cosecant of 90? Well, the cosecant is the reciprocal of sine. The sine of 90 is 1. The reciprocal of 1 is 1. So who has a sine of 1? And that would be 90 degrees. Now the next one says, who has a tan of √3/4? Well, that's not on our unit circle. So when we draw it, we're going to draw one in the first quadrant because it's positive, and that's going to be positive. Tangent is opposite √3 over adjacent, which is 4. And now we're going to find the third side. So we would do 4 squared plus √3 squared equals c squared. 16 plus 3 equals c squared. 19 equals c squared. So c is the square root of 19. And then the secant is the reciprocal of cosine. The cosine would be 4 over √19. So the secant would be √19 over 4. The next section, we're verifying identities. And if you don't see any clear-cut way of changing anything, and that usually happens when there's squared items on there, you can go to the Pythagorean identities, but you would change everything to cosine and sine. So cosine stays as cosine, tangent stays as sine of x over cosine of x, and then we can cancel out those cosines, so that equals sine of x, which is what we needed to equal. The next one, I would move the secant upstairs first, so we would have tangent times cosine of x. The secant moves upstairs as cosine because it's its reciprocal, and then I would change everything to sine and cosine. Same thing's going to happen here. That's cosine of x times cosine of x. Cross those out, and we get sine of x, which is what they want us to find. Whenever we see the squared trig functions, we're going to look at the Pythagorean identities. And cosecant is equal to 1 plus cotangent, cotangent squared. And secant is equal to tangent squared plus 1. But remember, there's a minus sign in front of the secant, so we leave that in front of that parenthesis, and we're going to distribute that minus sign throughout. So we're going to get 1 plus cotangent squared of x minus tangent squared of x minus 1. And this plus 1 and minus 1 bite the dust, and we end up with cotangent squared of x minus tangent squared of x, which is what we have up here. This next one is easy. If we put the secant squared upstairs as a cosine squared, because he's the reciprocal, leave the other cosine downstairs, we'll have 2 cosines upstairs and 1 cosine downstairs, and we can cross off the bottom one with one of the top ones, and we end up with cosine of x, and he equals what the other guy is. This next one's almost identical to the one we just did, except the secant goes downstairs as a cosine squared of x, and we can cross off one of those cosines with that cosine, leaving a 1 in its place, and that's equal to 1 over cosine of x, and he equals the guy on the right. Now this next one, the tangent can go upstairs as a cotangent of squared of x, so this guy can move up. This sine can come downstairs as a cosecant of x, and we are finished with that. So this one, we're going to move the signs to the left. So we have 3 sine of theta plus 2 plus sine squared of theta equals cosine squared of theta. And that cosine squared of theta is going to turn into 1 minus sine squared of theta. So we're going to go ahead and have 3 sine of theta plus 2. The 2 we moved over to the left side, plus sine squared of theta equals 1 minus sine squared of theta. So when I move all that over to the left, I get 2 sine squared of theta plus 3 sine of theta. And then when I move that 1 over, it's a negative 1. It would be plus 1. 2 minus 1 is 1. And make it equal to 0. So everything goes to the left. I turn that cosine into a sine using the Pythagorean ones. So now I have to factor it. I'm going to change to blue so you can see it separate. And this is going to be sine of theta plus 1 and 2 sine of theta plus 1. What times what is 1? And so when you've got the sine, what times what is 2 sine squared would be sine squared, sine and 2 sine. And what times what is 1 would be 1 and 1. And if you look here, 1 times 2 sine is 2 sine, and 1 times sine is sine, and that would be your 3 sine in the middle. So now I make those equal to 0. We would get sine of theta equals negative 1, and sine of theta equals negative 1/2 up here. And the 3 angles that would be is 210, 270, and 330. And that is your answer. So this next one looks very complicated, but it really isn't. I see on each side of the equal sign is a negative 2 secant of theta. So if you have 1 on each side, once I add that 1 and move it over, they're going to go away. So now I move everything to the left, and I would have secant of theta cotangent of theta minus root 3 secant of theta equals 0. And then I can factor out a secant of theta, and I have cotangent of theta minus root 3 equals 0, and I make each one of those equal to 0. Well, secant of theta equals 0. That means that the cosine of theta would be undefined, and there is no cosine of theta that's undefined, so he is not going to give us any results. Now the cotangent of theta would equal to root 3. That means that the tangent of theta is equal to the root 3 over 3. And the two guys that have a tangent of root 3 over 3 is 30 and 210. So that is the answer. Remember, the reciprocal of root 3 is root 3 over 3, and the reciprocal of root 3 over 3 is root 3. So this guy here, we're going to do the same thing we've been doing already. Sine squared of theta plus 2 equals, this would be 1 minus sine squared of theta, if we're going to change that, plus 3 sine of theta. Now I'm going to move everything to the left. Well, when I move that negative sine squared of theta to the left, it becomes a sine squared of theta. With this sine squared of theta, we're going to have 2 sine squared of theta, minus 3 sine of theta. And then you have the plus 2 minus the 1 would be plus 1. And when you factor that, you would get 2 sine squared of theta and sine, no square, sorry. 2 sine of theta and sine of theta. And then what times what is 1, and added together is negative 1, negative 3. So we would have a negative 1 and a negative 1. So negative 1 and negative 1. Now when you do that, you get a negative sine and a negative 2 sine, which will give you your negative 3 sine. So now we make each one of those equal to 0, and we get that sine of theta equals 1/2, and sine of theta equals 1. So 90 has a sine of 1, and the two angles with a sine of 1/2 are 30 and 150. So there are your answers. So on this one, you're going to also put everything on the left. So we're going to have negative 3 sine squared of theta minus 4 sine of theta minus 2 and plus cosine squared of theta equals 0. We need to change the cosine squared of theta. We're going to have negative 3 sine squared of theta minus 4 sine of theta minus 2 plus 1 minus sine squared of theta equals 0. And that'll give us a negative 4 sine squared of theta minus 4 sine of theta. And when we add the minus 2 and the plus 1, we get a minus 1. But I don't like when the sine squared is negative. So I'm going to change all of these signs. You have to change every one, otherwise you're not going to do it right, okay? So now we're going to have 2 sine of theta when you factor, and 2 sine of theta, and plus 1 and plus 1 equals 0. And when you do that, you get 2 sine of theta there and another 2 there, which will give you your 4 in the middle when you FOIL it back. And 1 times 1 is 1. So now we're just going to have 2 sine of theta equals negative 1 divided by 2. Sine of theta equals negative 1/2. And the answers are going to be 210 and 330 for that one. So this next one, we're going to change the sine squared to a cosine squared. So sine squared would be 1 minus cosine squared of theta equals negative cosine of theta plus cosine squared of theta. And when we put these all to where they're going to be positive, let's just move them all to the left and then we'll change the sign. It would be negative 2 cosine squared of theta, because he's there and he's going to cross the bridge and turn negative, and then positive cosine of theta, and then positive 1. But we don't like our cosine squared to be negative, so we're going to change all of those signs. And it's going to be 2 cosine squared of theta minus cosine of theta minus 1 equals 0. And when we factor that, we get 2 cosine and a cosine of theta. And we get, now we have a negative 1 and a positive 1. So we have to make it so that the inside's negative. So we're going to put the negative 1 over here, so when it multiplies with the 2, it'll turn to a negative 2. And the positive 1 will make the cosine a positive cosine, which will make it a negative 1 cosine. We make that equal to 0, and now we have cosine of theta equals negative 1/2, and cosine of theta equals 1. And the answers to those will be 0, 120, and 240. So this one here, the negative 3 tan of theta is on either side of the equal sign, so you can get rid of them. And then you're left with this equals 0. and they have a cosecant in common. So it's going to be cosecant of theta, negative root 3 plus tan of theta equals 0. So you do cosecant of theta equals 0, which means the sine of theta is undefined, which is not possible. So he's not going to produce any answers. And then you're going to get the tangent of theta equals root 3, and that's going to give you two answers, which are 60 and 240. So that is the answer to that. So for the last one, we see that there's a negative 3 secant on each side of the equal sign. So when you add one of those to the other side, it's going to bite the dust. And now we have square root of 2 sine of theta minus sine of theta secant of theta. And they have a sine in common, so we're going to take out a sine of theta, and we have square root of 2 minus secant of theta, and that means that's equal to 0, and that means that sine of theta equals 0, and that is 0 and 180. Let me change the color here. 0 and 180 have a sine of 0, and we have that the secant of theta equals root 2. That means the cosine of theta equals root 2 over 2, which is the reciprocal of secant. When you put 1 over root 2 and then you multiply by root 2 over 2, you get root 2 over 2. So that would be 45 and 315. So those are your four. Let me put it in red. 45 and 315. Those are your four possible answers.